In this video, we're going to be talking about three-element control and how we use it in order to regulate just how much feed water is going to our steam drum and correspondingly how much steam we're generating and discharging from our steam drum. Single element control is the most basic form of control used to regulate the feed water flow rate into the steam drum. To explain this as easily as possible, I'm going to go all the way back to the first designs that we used. Essentially what we had was a float within the boiler drum. The float would move up and down. As the float moved up and down depending on where the water level was within the boiler drum, it would open and close a valve proportionally. Imagine for a moment that we suddenly get a very large demand for steam, and this steam needs to be taken from our steam drum. We get a reduction in pressure, and that leads to a corresponding rise in boiler feed water. So we're measuring a rise in boiler feed water, which tells our feed water control valve to reduce the flow of feed water to the steam drum. The problem here is that what we should be doing is increasing the feed water flow rate to the steam drum. We should be opening the feed water valve. The part of the table that I think is the most interesting is the measurement row. Here you can see in the single element column, we've got two measurements, drum level and drum pressure. In two element control, we've got drum level, drum pressure, and the mass steam flow. And in three element control, we've got the drum level, drum pressure, mass steam flow, and mass feed water flow. Irrespective of what kind of element control we're looking at, the best kind of control is one where we control the mass balance of the steam drum. But it's very important that that level does stay within those defined limits, because any deviation outside of those limits could lead to damage on our heat transfer surfaces, pipes melting, pipes rupturing, water carryover to our steam turbine or processes, water carryover to our other heating surfaces such as the superheaters, and this may lead to things like scale developing on the inside of our heat transfer surfaces such as inside the tubing, and this again will reduce the heat transfer rate for our tubes, which gives us an uneven thermal distribution across our heat transfer surfaces and increases the likelihood that we damage our boiler tubes.